Hello, my name is Jasmine Shukri, and today I'll be talking about my final project that I did for my ECE 528 class. The project involves a drink classification in a fridge. Let's get started. To start, let's define the problem of the drink classification. So the initial idea of it is to have a camera inside the fridge, take a picture of what's inside, the initial racks that you see usually with the fridge, have a pre-trained model evaluate the image, and then output the predictions based on its parameters that it was trained on. So think of it as a kind of like interface, let's say, interface with the user where the model predictions are output onto a separate screen or monitor, probably stuck to a fridge or embedded into the fridge. The main motivation behind that was my 202 project, which was a mini vending machine. I just thought that, having a something miniature like that is readily available somewhere else. I thought that was a cool idea. Maybe I wanted to expand on it. So I thought, let's just have it more intricate. Let's have it more, how should I say this? More specific, let's say. And I thought that maybe classifying drinks in the fridge could be like sort of a convenience problem more than a crucial problem that risks people's lives or anything like that. It's more of a convenience thing that I thought people would find something useful really for their everyday lives. So for this slide, I'll just have my camera off just so you can see the link of from where I sourced the image that you see on the right there. As part of the technical challenges for this project, it is supposed to be implemented on a Raspberry Pi 4, which in my case is the first time I'm deploying a model or anything related to that onto an embedded machine. It's my first time working onto an embedded machine. So that in itself poses a technical challenge for myself. And adding on to that, I plan on using a camera model 2 from Raspberry Pi, as well as photoresistors, or in other words, LDR, light dependent resistor modules. The plan is to use those two external components in parallel such that the light resistors become the trigger for the Raspberry Pi camera. Then by doing so, we have the camera send its image to the model, and then the model would have been pre-trained by then, and from there the model would predict the image as discussed before. Now, initially, the model was supposed to be this huge amalgamation of different machine learning techniques like object detection, pruning, and quantization, the whole 9 yards, let's say. So it was really a big project, and I think the scope is really big for this project. And because of how big the scope was for this project, I think, especially considering that this will be my first time deploying on an embedded machine, then the scope itself is also a technical challenge, I think. As far as related works go, when I did my research regarding this topic, I found almost no papers on this specific issue, which is something that struck me as odd. I thought people would have done this already, and maybe I just didn't search hard enough, but I searched far and wide through Kaggle, through Google Scholar. I searched a lot of places and still nothing related to what I've been doing. So I really had to resort to using or reusing code from the lab assignments throughout the semester. Considering that there's almost no research from what I found, I thought that this could be an interesting avenue for research in the future, maybe something to get invested into once I gain more experience or have someone alongside me to guide me through this. In the end, though, a lot of code from the lab assignments was reused, and that kind of smoothed things over, I want to say, quite a bit. Now we move on to the approach and results. And well, here's where the bad news starts. Many failures occurred when I wanted to implement this onto a embedded machine. For example, when I first booted up the Raspberry Pi and tried installing TensorFlow on it, there was this error about shared object files that I just could not find a solution for online or anywhere else. So the whole embedded machine thing had to just be thrown away completely. And also with weight pruning quantization, data augmentation. Weight pruning also provided an error, also produced an error that I had encountered before. However, I was not able to find a solution to, or at least I don't remember the solution to it. And even after searching, I couldn't find it, so we had to discard that part as well. With the data augmentation, though, the results did appear. However, the data augmented was also the validation set, the validation data set was also augmented, which is not recommended, not strongly recommended in machine learning. So, and considering the implementation that I did for my project, there was no easy way to split up the validation data set with the training data set. So I had to also throw away data augmentation. So what essentially happened was you have a small piece of code, it's essentially like a lab assignment. We did get relatively high accuracies, close to 100 in some instances, but the data set was so small, 285 images for training and validation and 15 only for testing. So considering the small data set, it is easy to imagine that the accuracy would be really high. Another technique that I discarded, even though I didn't really want to, was object detection. But object detection was discarded for the simple fact that it is a really advanced topic that when I looked into, I thought I'm not experienced enough to try and implement this into my embedded machine. There was the challenge, which I liked, but I was working on a time constraint that I set for myself, and just discarding the object detection just seemed like the better choice in my opinion. And finally, I'm going to talk about the broader aspect of my project. So I like to call this the newborn phase that my project is in, meaning that there's a lot of sub-problems to solve. There's a lot of improvements that can be made. It's essentially like a newborn baby. You have to really care for it and give it everything you can and help solve its own issues, you know? So as such, there's little to no impact yet. I say yet because there is definitely a plan to get more experience in this field of embedded machines and machine learning. And maybe, like I said before, to work alongside someone with high level expertise and help me guide through this project that I decided that I wanted to do for myself. As far as limitations go, the model is still in the collab environment and it's not deployed in embedded machine yet. So maybe there is some sort of compatibility issues that I'm not aware of. But the potential definitely is there for this project to be something groundbreaking. I definitely believe that. That's all I have to say. Thanks for watching. And if you want anything to do with the project, you want the code, you want to help me, just let me know and I'll shoot you back a reply. Thank you for watching.